All right. So, welcome back. Been doing some research. I'm trying to become a little more wanted to save a lot of silences on this video of me reading a bunch of documentation. Um, but I'll go through quickly what I went over. So I spent a lot of time on OpenID uh, on their website and in all their specifications. It is crazy how large the ecosystem really is. How just beyond the specifications, um, uh, how many of these implementations are certified, uncertified, or created by the federation themselves in some way. Um, uh, and the implementations are not just for the relying parties, but also OpenID provider libraries, and then even financial grade uh, providers and relying party implementations. Very, very interesting. I mean, it's very deep, and I mean to an extent, uh, uh, there is a small piece of me who that feels like this is exactly what I was trying to create, and I've learned about it through this project. But there's another separate kind of stage of like, um, this is really solving the authorization question to a huge degree, and this is, the authorization between the service provider and the user uh, using a shared trusted central authority that is my identity and access management system. Um, but the authentication itself is really offloaded to the identity and access management system. So authentication is still very much in the wheelhouse and still, not defined by these standards. And thus, I think I'm going to try and focus more on that in my design because I'm never going to replicate the thoroughness and detailedness of this design, nor the accuracy, right? But in any case, very interesting stuff. Um, the implementation. This is the kind of thoroughness I'm talking about. I mean, it is so detailed that I would not even want to try to replicate any of this content. I will always default to this. Um, oh, went through the RFIDs on JSON web tokens, uh, web signatures, web encryptions, web keys, and web algorithms. That is its own little ecosystem of documentation that is interesting, right? These are things that I love it when a standard um, shows things that you wouldn't think need to be standardized. Um, but it's a problem that everybody runs into, and by standardizing it, uh, it alleviates all of these design decisions, provides some comfort, and provides uniformity across applications, which is what standardization is supposed to do. It's not necessarily like um, it's not always a requirement of implementations, but it is guidelines that promote security and uniformity across an environment, which is, kind of a beautiful thing. So that was very interesting. The idea that they nest together to provide different features to the underlying information that you are trying to, you know, uh, uh, transfer securely, whatever that means in that context. Very cool. Uh, oh yeah, I also spent some time on Auth0, which I think is like an Okta platform product. I just thought it was cool at the bottom here when we look at features. So this is like a real platform by a real company that's built one of these products, sells it to many other companies. And some of these features, universal login, single sign-on, multi-factor authentication, are things that I've been trying to cover in this design, right? And I've talked about a lot, or learned. Really, I've learned a lot about it. Talked a lot about things I didn't know about. Um, but then also there are these other features here like breached passwords, passwordless, machine to machine, and actions. I don't even know what this is, right? Which are things that I just didn't particularly cover, but read about a little bit in SAML and uh, OIDC implementations. So that was cool. Um, yeah, and then these are ideas that maybe I haven't really talked about, right? I didn't really talk about fine-grained authorization that much. I have talked about cloud deployments, authentication, of course, right? These are kind of outside of what's going on here. These are like qualities, extensibility, security, user management, um, access management. So just interesting to see that a lot of the same topics that have been discussed here are obviously, real features being discussed by, companies trying to sell products that are real solutions to these. Okay, one other thing that was kind of an open item last last video that I wanted to talk about a little bit more was the biometric information of the something I am, trying to figure out how to um, see how do you actually capture biometric information. I was curious about this, right? And this Wikipedia page has been interesting, talking about the qualities of biometric information that make it good for authentication. Uh, why some traits are good for biometric authentication and others aren't. Um, but this, I think, was my favorite diagram because this is kind of in line with what I was guessing at in the last video, which is that there is, some sort of raw information that's being picked up from a sensor, and they are extracting some sort of features or patterns from that information, and that's what's stored, and that's what's you know used in the authentication process itself with new information, right? So there must be some sort of qualities that you can measure and collect reliably in such a way that, even if your finger is tilted a little sideways, we can still verify with some accuracy that that's your fingerprint, right? So there must be some information, and that's, obviously I'm not going to go down to that level, but it is interesting, right? Samples matched with reference models to generate genuine and imposter scores, right? Oh, that was another thing, right? Like, really, you're just checking like the likelihood that this new fingerprint is the same as the old one, or this voice is the same as the old one, or this um, uh, face is the same as the old one. I think that's what we did: voice, face, and fingerprint, right? So genuine and imposter scores, those are the likelihoods, right? And calculate if they pass the threshold to determine a positive identification. Called enrollment. I like how this stuff kind of has official names, right? Okay, so I think there's two ways that we could theoretically do this, right? We could have our own devices, right? Like if you think about like in a physical, biometric information is interesting because it's a very physical medium, kind of like the smart card, right? If you want a smart card, then you have to provide the card to the person, or the USB drive to the person, or the chip to the person, right? Similarly, with something IAM, you don't have to provide it, but you have to physically, read that from somewhere. And you have to trust the device that's providing that information, right? And then someone has to secure the existing reference information, the stored templates from the diagram, right? So this could be biometric information. That's what this is, I think, to a certain extent. But then there could be another layer to that of, the authentication device applications. Your device may have a public key that it only provides to the system when certain biometric information is met. But that'll probably be controlled more so by the device than by me or the application, right? So I still think, we've kind of laid out everything correctly, and for this case, we're going to say that this is we're storing our own information, right? Or, and this is another possibility that I don't think I'll get into in the diagrams to cover it, but I think probably in most cases. There are other services or solutions that just store biometric information and perform this matching, who then maybe also have devices, right? And they can kind of provide this type of authentication as a service, right? Like, they have partnerships with manufacturers for fingerprints, scanners or face scanners or voice scanners, and then they hold information, and somehow in the chain without me, I can trust them. They have a special URL that I can trust where I can, say, hey, this person is using this device and this is the information they're giving. Can you guarantee that it's this person? And they, derive that for us. Okay, I think that's everything on that. So let's see if we can make an actual diagram now. Wow, this stuff feels like so long ago, doesn't it? Kerberos, jeez. Always. Okay. Let me see if I can start up that server again. And we can make a couple diagrams for how this will really work. So authorization is now platform-wide, and this is solved, right? There's authorizations for particular users, for particular applications, and for users between applications, which is pretty cool about OpenID Connect. Like I said, it's really an authorization platform that solves that hurdle, I think, quite a bit more than authentication. Like authentication, right, is still up to the individual application, or to the individual OpenID Connect provider. Okay. And then accounting, we said would be service specific. Okay. And I want to add, look at this, our first one, single sign off ended up being, or single log off, I think is what they call it, ended up being really important. Okay. Okay, so let's build it out. All right. There we go. Okay, and what did I even have? Man, it feels like so long ago. What was even in that original document I was trying to make? Okay, we had a client device, a service server, user info database, authentication server, generate token, perform MFA. What's interesting is OpenID Connect kind of solves the whole service server communication business and providing those tokens. So I think it's safe to say that we want to rename kind of everything. So this is the authentication server, and it is going to perform MFA to a certain extent, instead of token generation. So let's start off by saying there's an OpenID Connect provider. These all have to be connected. Here we'll say OpenID Connect provider. There we go. And is it possible to put all of these? I'm gonna have to open up my my documentation here for plantUML. Let me get the documentation out. Oh, let's not do the sequence diagrams. Let's see. Use case diagram. Let's see, package. Let's see, is there a good deployment diagram? Maybe that's the way to do this. Okay. So let's put everything in my... Oh my gosh, I forgot to mention. I think for this series, I'm going to call this Doorman. That's probably already been used 1,000 times by the security industry and by other software. It's a little low-hanging fruit. But I decided that's what I wanted to go with. This isn't a real product anyways, right? So, okay. Let's have a cloud be the platform, right? And there's a cloud. Is that what you use? Oh no, it's braces. Let's do that. It's big, and we say platform. Okay. Here's our platform, and then inside that we will have this OpenID Connect provider. What's going on there? Is it because I can't have nested things? No, that can't be right. Things have to be able to be nested, right? Component 1, component 2. Is nothing nested in the deployment diagram? Ay, ay, ay. Oh, nestable elements. Here we go. Ooh, but rectangles are nestable. How do they nest? Ooh, they nest with braces. Okay, hold on. Let's see if this works. Let's close it. But then maybe we can't have platform. There we go. Platform as platform. There we go. Did that work? Or maybe cloud platform as platform. Here we go. What is the point of this? Okay. So let's say we have our platform and we have our OpenID Connect provider. What else is going to be in there? The authentication server here. And I'm going to get rid of generate token because it's a little unclear to me. And And then we need our database, info database. And then what is not necessary, but likely, is that this will also be running inside the same platform, right? And the client device is what's outside of it. Okay, client device down here. Let's get rid of these interactions. This is just a deployment diagram, right? And then there's got to be some sort of orchestrator here, right? And can I use node for these? Node orchestrator. Okay, so the orchestrator is above it all, and it is, do we have good, what do we got going on here? I need a, okay, this is, plantUML's site is absolutely covered in advertisements. Let me see if documentation PDF, we can get a, there we go, the language reference guide. Okay, all right, finally got it up. Let's go down to a deployment diagram. What kind of arrows do we have here? Okay, let's just point to all of them for now. And so we'll say orchestrator. And is there a way to say multiples? Or to choose direction? Oh man. Round corner. Oh, that's cool. I do like rounded corners. Okay, I think we're missing the point here. Okay, maybe it'll just work. We will see. Okay, orchestrator pointing to that one. Okay, let's make a couple of these. The authentication server, the user info database, and the service server. Okay, and then is there a way to say on top of? Declaring element, skin type, appendix, all the arrow. Oh wow, you can mix use case component and deployment elements in a class or object diagram. Good God. Okay. Orientation. Well, that did nothing. work if I put it up here? No. How do you get a top to a bottom direction? Oh, yeah. Okay. Alias. It says that that's the default, but that's not what I'm seeing here. Seems strange. Is there no... oh, you know what? That's bananas. That doesn't make any sense to me, but at the same time, kind of does make sense. Okay, this is looking good. Okay, so we have our platform, which has an orchestrator with, and see, I think connect provider should be node. Is there like multiple nodes? Is there a thing for that? Like a deployment use case. I assume that there's like a queue, rectangle, stack, node, collections. However, is collections like collections kind of shows that there are multiple collections, right? Let's see. Collection. Providers. Does collections not work? Component. Long description. Collections. Ooh, but its collection's not nestable. Oh man. It is not. Okay, storage, stack, Okay. I wanted to show that there could be multiple pods. Maybe I can just. Oh, you know what? I know how to show that. That should be in the arrow, shouldn't it? This should be a one-to-many arrow. How do you indicate that? Let's see, arrow elements. Oh my gosh, these diagrams are insane. I don't need anything that crazy. Let's see. Changing the color, the thickness, the dottedness, the end points, the beginning points. Is there a proper way to put text on the arrow? Yeah, something simple, a little one-to-many. Oh, is that what these little markings mean, maybe? Let's see. Right, up, down. In a class diagram, is there like a relations? Ooh, this is like specialization, realization, dependencies, really. Okay, the orchestrator scales. Ooh. Orchestrator scales all containers. PKI we'll say trusted certificate authority for PKI. Ooh, and we should also say distributes certificates. Okay, and then I think I can also just put Kubernetes here. Is there a term for the leader? Kubernetes cluster. Basic question. Gonna have to, I bet you in this series I'm gonna have to learn a lot more about all cluster data, kube scheduler, kube controller manager. Okay, so there's a bunch of the master node, the control plane. Okay, beautiful. We can say Kubernetes control plane. Okay, so the orchestrator, and maybe I shouldn't even be calling this orchestrator. I should be saying Kubernetes control plane. I like the term orchestrator. You know what? I'm gonna leave it in there. Okay, so we're talking about the Kubernetes control plane, scales all containers, trusted certificate authority for PKI, and distributes certificates. So it's doing all of these things. Scales containers. I won't say all. Let me just say scales containers, trusted certificate authority for PKI distributed certificate, and this is like a giant box of stuff. So, but that's probably handled in a different video, right? I mean, that's not really part of the IAM. It's just maybe I should have done this as the first in the series to base everything else off of. But I was interested in Doorman, which reminds me, title Doorman. There we go. Okay. So the next one is our OpenID Connect provider, who, let's see. Oh, and then this arrow is there a way to put like a 1, 2, any? Oh, that's cool. Oh, is that a name? Like if I put it on another arrow, does everything break? No. And instead of many, I'll just put n. 1 to n. Okay. All right. Okay. So the OpenID Connect provider is going to have interfaces on it. For interacting with the services. Now, one other thing is that I keep putting the services inside the platform because this will matter to our services too that are part of the platform, but there are probably services outside the platform that we're going to try and integrate with, right? So we should have external services too. And this is left to right, so let's put the service server. Let's say internal service. And then let's have an external service too. So I'm going to put the internal service. We can show both of these kind of here, internal service there. The first thing, and let's not get too into the user info DP. We'll just say it's 1-to-1 for now, but we'll probably need something else there. All right. Okay, so this, I put service server. Okay, that's strange. Internal service, let's call this internal service. Relying party, just so that's clear. Okay. Now we'll do the same thing for our external service, which maybe should come before the platform. I don't know, client device is down here, which is also strange. How does this not break our graph that we have 2 internal services? Oh, it does. External service. Okay, external service, then client device. Client device should definitely be before that. Oh, I get it. The only reason platform is coming after these is because it's nested. Okay, let's draw our diagram like that just to make it a little simpler. Okay, so we have a client device, an external service, and then an internal service. And these are both going to be communicating with the OpenID Connect provider. So we'll say relying party, service interface, right? Service interface. Actually, the interfaces will be captured by the actual interface icon. Let's see, how do you get an interface? Can I just put one in? Interface. No. How do the interfaces work? Nested elements. Mixing deployment. Oh wow, there's all these appendices. Nestable elements, here we go. The interface is not nestable. Wow, that complicates a little bit. Let's see. Oh, sorry, nestable. They use nestable to mean things that cannot be nested in. Let's see, interface. Yeah, it's just showing up as content. Could it be at the top? No. If I define it, no, that doesn't work. How in the world? Oh, because it's supposed to be in braces. There you go. Whoa! It's a class diagram interface. Hold on. How did that happen? How do they create interfaces? They have interface 1, braces. Okay, let's go back. If I do. Anything? No? How is it not possible to show the interfaces? Oh, well that's because I'm doing, okay. There we go. There we go. Darn. Nothing. Nothing. Is there a way to put in like braces inside of here? Wow, it all just is inside of it. There's no way to deal with that. Okay, let me go to the nestable. How do people generally create information that then, like, do you have to choose whether you're a parent of a nesting object or information? Or is there a way to have information and then also nest? Yeah, I don't see anywhere where they nest and include information. Like you're one or the other, which is unfortunate. Okay. Relying party. What other information? If I don't have the interfaces, I mean, we'll have a line between the client and the external resource, right? So like, client or client device. Maybe we can use an agent for that because the client's not doing it directly. Let's see, agent client device. Can I just put quotes on this and then have a space? Is that, no. But that's allowed. Oh, it thinks it's a sequence diagram. Okay, then let's not do that. Okay, component diagram. Nope. Class diagram. Okay, and then what's the failure? Client device to external service. And if I just put one, it goes to the right. Okay. We do client device external service and then client device internal service. There we go. That's kind of nice, right? If I do this. There we go. Okay, so here's our external service and here's the internal service. These are both the relying parties. Let me put in OpenID connect client, relying party slash OIDC client. Maybe we don't need a slash, we can just do relying party OIDC client. Okay, so these are the relying party with the OIDC client. The client's connecting directly to those, and I shouldn't say client, it is client device. And I have an agent here. Is that not, doesn't the agent look different? Or is that just how an agent looks? Agent is just a rounded rectangle. Do we want an actor in there too? Actor. See, I don't want to call this client. Let's say user and user device. Because client is now being used for OIDC. I don't want it to be confusing. Okay, use actor, user. Where's that? Oh, it's all the way on the other end. Oh, it's the other way on the other end. User device. User device. There we go. Okay, so the user goes onto their user device, which interacts with the external party and the internal service. And then we need like interacts through. Yeah, we need to define all these edges. I'm just creating random edges. Nobody knows what they're for. We'll say connects to or uses. Yeah, maybe uses this service. Okay, so the user interacts through the user device, uses these services. Okay, and then the authentication happens with the OpenID Connect provider. And let's have another name for this, because I'm going to put OIDC provider down here. Let's say OIDC provider. Oh man, okay. Let's call this the identity provider. I know that's stepping on SAML a little bit, but that's still how I think about it, right? The identity provider. And okay. Okay, so the identity provider, the OIDC provider, right? Let's see, there's a connection there for like authorizes, right? And that's from the identity provider to the internal service and the external service. Okay, things just got very complicated in this diagram. The identity provider is all the way at the end. To put this up here. Okay. Oh, but then the user device and the external service and the internal service end up at the very end. Okay, so I like the idea of user and user device coming very early here. Let's try and clean that up. Not that that will help our current issue. Okay, and then we have an external service and an internal service. Does nothing. This is probably okay. It's underneath. And then why is the identity provider so far away from like authentication server and user info DB? This ordering is strange. Oh gosh. I just need this to be second. So identity provider is after, no, is before authentication, user info DB, and then before orchestrator. What if we go after internal service in here? Nothing? Why does it go all the way to the end? Okay, how about this? What if it's the internal service and the external service going to the identity provider for authorization? There we go. Okay, so I can specify direction, more or less. Okay, then orchestrator to internal service should be left. How about that? I should specify the direction of every single arrow. That's just what I'm going to do. Okay, so this is right. Okay, and then user device. I want that to be on the left. That looked good. So user device should go down to external service and right to internal service. That didn't seem to have any effect. Whoa. I just want to be clear that this is exactly what I'm going for. And now I just want the internal service to come down to identity provider and the external service to come over to identity provider. User device. Is not going right to internal service at all. I mean, that's just a lie. Okay, I'm going to continue in this way. I assume at some point it will revert back because that other way satisfies all of my arrow conditions. I mean, even orchestrator left internal service. How do you get that? If I say right, user info database. Oh my gosh, it's so close. It would be perfect if external service was down here. Shouldn't external service be going right to the identity provider? And it's done. There it is, folks. Okay, so the user device uses the internal service and the external service for authorization, or uses both of those, and both of them come to the identity provider for OIDC. And the whole point of this is just to show that there could be an internal service or an external service not provided by the platform. Then there's this user info database, and the authentication server platform. Okay, so this should also be a node. Honestly, internal service and external service should also be nodes. They're all nodes. Then the authentication server. I'm using node here, but they're containers. There's just no good container object. Okay. Okay, so this is user info database. I'm just going to say that there's a server wrapping that in the diagram because I think it makes more sense. or I could wrap it in a node. Oh, that would be interesting. There you go. There you go. We'll say node database wrapper. There you go. Database wrapper. Can I say as database wrapper? Or is it this one that can have a space because this one doesn't? No. Neither of them can have a space. All right. Well, that's what the point of that was then. Okay. And then really, instead of the user info DB, it's the database wrapper that we're pointing at to the right. Wait, why did that all change? What happened there? Why is this here now? Orchestrator should be pointing right to the database wrapper. Oh, is it because it's nested, it's coming first? I thought nested came last. Hold on. There's a thing about nestable diagram directions. Smetana. Simple element first, then nested element. So how do I say Smetana? Because this says nested element first, then simple element is the default. Oh, Pragma layout Smetana. There you are. Okay, here we go. Our database wrapper has our user info database. There we go. And like I said, maybe there's some sharding going on here. I'm not going to try and figure that out right now. User info database. And the database wrapper. Okay, so this authentication server, to perform the authentication, this is where I was wondering if it would make sense to have different containers for different types of authentication, or to handle the authentication methods in a different container. I don't think that actually makes sense, because you're going to have some sort of authentication session with the user where they're providing this information or you're walking through this. So you want to head on that session that manages the session. And then you might have microservices that are processing, are helping send the text message, or initiate some sort of connection. But you want a management for that. You want to manage that session somewhere. Yeah, so let's say MFA microservice is a separate thing. Oh, you know what? This is where I can use collections. here we go. Our MFA microservices are off to the right of the authentication server. And then the user info database has to also be managing the existing sessions, which is something I don't think I covered earlier. Okay, so the user device will at some point try to reach the authentication server. Let's put that down here. To be clear, after the identity provider goes right to the authentication server. Okay, hold on, let's get rid of this. Okay, the identity provider, or should the identity provider actually just go to does the identity provider go directly to the database wrapper, or does it go to the authentication server? I'm trying to think about this, right? Like, it probably makes sense to go through the authentication server or a authentication server. Okay, so this is kind of the master of authentication to a certain extent, right? And it has a database, it has a identity provider, and it has these MFA microservices. I mean, if anything, that's really the doorman, is these 4 pieces here. So maybe those should be kept kind of as a separate thing. Okay, let's do that. The orchestrator, the internal service, and then we can have not node, let's say rectangle. IAM. That is all of these. Oh, you know what? But collections is not nestable. No, wait, sorry. I keep getting what nestable means confused. Okay. Okay, and what's wrong with this? What is going on here? plantUML. What if the orchestrator just has the IAM down? Okay, sorry. Before I change all this, let's see if I can figure out what's going on here. User is giving 26 lines. Rectangle IAM. Syntax error. Why? Brace. Bracket, 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 brace, brace. It's nested. It doesn't have brackets, it has braces. That's what this is. Whoa, okay. Look at that. So this is the IAM machine. Oh, you know what? I bet I can do it with quotes here. Okay. There's a user info database, and then there has to be a database. User info database session management. Say user information and session management information. Okay, they go to the identity provider. Identity provider goes to the authentication server. Authentication server. This is getting good. We've almost got this diagram down. What kinds of diagrams did I say I was going to make? I know at the beginning I was like, I'm making a ton of diagrams, which I still do want to do, but let's see here. Deployment diagrams and use case diagrams. Okay. I might hold off on the use case diagrams. I think I might get this deployment diagram done and then try and add some extra information about my database schema. And maybe APIs. I think I still have to cover APIs to a certain extent. Okay, maybe that's where the use cases come in. We can have one full use case of single sign-on and single sign-off. Okay, so user information, session management information. Let's see, MFA microservice, multi-factor authentication microservices. Okay, so at the end of the day, the identity provider comes to the authentication server for, and I should say creates 110 on all of these. And then for this one, I just say creates. You know what, maybe I don't need actually 1 to n. And I can just put on the identity provider, OIDC provider, many instances. Many instances. Okay. The identity provider goes to the authentication server for authorization, for authentication. Oh, there's another type of information that we need in this database, obviously. there's the user information, there's session management information, which is necessary for the authentication. But then there's also got to be authorization information, right? Such as roles, groups, and maybe that's user information to a certain extent, but also individual application use, right? So what do they always say? RBAC, RBAC? I don't know what that stands for. Let's see if we can find that out. Role-based access control, security model. Are there any alternatives? Attribute-based access control lists, policy-based access control, relationship-based access control. In OIDC, you're giving specific information. That information, like that agreement, right, is probably also somehow kept. What information different parties want. So let's say RBAC, PBAC. So maybe it's role-based, policy-based, and then kind of claims-based, right? OIDC claim. Which services claim which information and that the user has agreed to. So like, yeah, like user service authorization. Claim access, not the information itself, right? The information itself is probably user information, but claim access is probably carried out somewhere else. Yeah. And I'm imagining for this, yeah, we're going to have to talk about the schema for these other two, how that would work, right? But this is generally how we're doing it. Okay, so there's the internal service, the relying party, the external party, the identity provider, orchestrators creating everything. Okay, the authentication server manages authentication sessions, many instances. Okay, so the user device is going to have to directly, and this is going to destroy my diagram, but one way or another, the user device is going to have to go right to the authentication server at some point. Oh, it flipped. It flipped the authentication server and the identity provider. I still want the identity provider on the left. Oh, and you know the authentication server is going to have to go to database wrapper. Maybe that's how I get this to work. It's a complicated diagram. Okay, the authentication server is going to talk to the database wrapper, as is the identity provider. Okay, there's something, it's not going to work here. Okay, I refuse to think that things have gotten too complicated this early. I imagine the way that plantUML works is that you'd, if I give it a direction on every single arrow, it's going to try and satisfy as many of those requests as possible and give up on a few, right? And it's probably very utilitarian in that. In that sense, if I can theorize a design where all of the arrows work, then I can trust that plantUML will find it. Okay, so it's looking more and more like everyone touches the database, or everyone inside the IAM solution touches the database, which I think is okay. We can discuss that more at another point. But let's say that everyone who touches the database wrapper, right, is going down. And let's see if we can put the database wrapper underneath everything else. Right, so the authentication server and the identity provider both go down, right? And then it's the orchestrator that's coming around here to create it. And then the microservices I also want to go down. And those are going to be after the authentication server, MFA. Okay. And let's say these all read. Read. Oh, wait. Reads. So MFA is going to be reading, identity provider is going to be reading, but also writing. Reads, writes, and then reads, writes here on the authentication server. Okay, so that's important. Because there's going to be new authorization information that gets made, and there's going to be new authentication information that gets made. Okay, and then, gosh, I still really want to switch these. Do I have identity provider write authentication server? This down here at the bottom. I wonder if it's not utilitarian, and there's some sort of angle to this all. No. Doesn't matter. Second it exists, we get back to this. Okay. Okay, this should go up there though. It's internal. The question is, how do we get the authentication server to come after the identity provider? And it has because in my design, the user device does not go directly to the identity provider. It always goes to the authentication server. And they basically just share session information in the database wrapper. It can write authorization information and read it, but it can only read session information. Same thing, this can only read authentication information. This can write authentication information and read authentication information. So maybe that'll have to be defined somewhere else. How do we get these two to flip? Oh, the authentication server has to talk to the MFA microservices. Duh. Oh my gosh. And this is a two-way thing. What if I say, and this is probably ridiculous, but what if I say that the authentication server has to go left to the identity provider? Nothing. Same thing as saying the identity provider has to go right. I swear to you, this would be simpler if these just flipped. I don't know why it's doing this. Ay, ay, ay. I guess these are kind of inside IAM. Right? These two can go like up here. Are there any other arrows I'm missing that I guess might help before I play around with this anymore? Database wrapper, the user information, session management information, PDAC, internal service. What if instead of left or right, it was down? Whoa. Okay, hold on. There's too many arrows here. Okay, so the internal service and the external service both meet with the identity provider. Does the provider, okay, so one thing I'm thinking is, could the, yeah. Would it be better if the OIDC provider, now that we've said that the authentication server is really just managing authentication sessions and is meeting up with and is directly interacting with the MFA microservices, is it possible that our identity provider and our authentication server could be merged in such a way that yeah, I wonder. Because there is an extreme amount of complication here. I mean, it is getting difficult to make sense of all this. Let me make sure that the OIDC provider's authentication, because what I'm basically saying here is that, like, the user tries to log into the external service. The external service sends something to my identity provider. And then how does my authentication server reach out to the user device? It's got to be the identity provider that manages that session. I think the identity provider has to manage that user authentication session. That might be defined in OIDC, right? Let's see, actually. Yeah, see, the OpenID provider, because there's like redirection happening on the client. Okay, so maybe it makes sense that these are merged and this is managing authentication sessions. Okay. Let's call this the authentication provider. Authentication server manages authentication sessions, and it's the OIDC provider manages authentication. All right, and then we get rid of this. And then we don't need this. To the right, okay. There we go, successfully merged. So the orchestrator is creating an internal service, creating internal services. There are also external services. The user uses their device to use the internal service or the external service, and then we can say authenticates to the authentication provider. And then they come this way for authorization, and then authentication server comes to the MFA microservices for authentication. They read. This is managing the authentication sessions and the OIDC provider for services, for the relying parties, I should say. Then there's read writes down to the database wrapper that's managing session management information for authentication. You know what? I kind of just want to put this for authentication and then for authorization. The MFA microservices are reading this information, and then the platform also creates. Many instances. Because ideally, I mean, we get here, the user's going to have to select how many microservices. We're going to have to initiate those procedures. The microservices may not come back to the user device. I mean, that's another part of this, right? The MFA microservices may reach out to other devices or other things. Okay, I think this is as good as we're going to get it. I think this is excellent. Okay, this is our Doorman solution. I'm just going to call it Doorman. I know it's a solution. It's a design for a solution. It's not a whole solution. Okay, so this is our deployment diagram. Let's stick with this until further notice. Let me make a little folder for and then Doorman And then let's save this into a new text file. Ooh, and I also like, yeah, let's do it like this. Okay. All right, there we go. We finally have a diagram. Took a long time to get to a diagram in a system design thing. Now, there's another thing I didn't touch on here, which is like, you know, how many sessions are coming into these servers? Is this the kind of thing where we want a authentication provider is the name. You know, that's another thing I see in a lot of system design videos where they get really hung up on like the load balancing and the caching and all these things, and those things are really important, right? The optimizations for a system that are definitely much easier to make at the design level instead of after that. And maybe those are things I can touch on, like maybe we might revisit Doorman in a future installment of this series. Maybe we come back to Doorman, I don't know, months down the road, and we see if we can make those optimizations and get further. But I think this is a good high-level idea to understand like how an identity and access management platform, what the requirements really are, right? Like this authentication provider has to be an OIDC provider. And in this case, it also has to manage the authentication sessions with users. Maybe that should also be clear. Manages user authentication sessions. And then there are many instances, and then you know, there's a lot of pieces to this, right? So many ideas that I discussed while making this that didn't make it into the final design, which I think is probably good. Okay. So let's see, what else? I was going to make some use case diagrams. Let's see if I can define exactly which use cases I need to account for here. Diagrams for real. Okay, diagrams for use cases. Okay, which use cases though? And then, oh, and we also want our DB schema. Finish DB schemas. Okay. Okay, and the schemas we need, we already have the personal information or the user information. We need session management information, and then RBAC, feedback, OIDC, and claim access, that kind of business. So that's kind of clear. And then we need diagrams for use cases. Let's have see, I wasn't going to cover OIDC. Let's not cover OIDC, but the authentication. So step number 2, how does that work? So there's the authentication use case, and then the single log off use case. Those two use cases, right, are kind of unclear. Single log off. What about, do I want to cover, see, I don't want to cover OIDC, but it feels weird to cover single log off without covering like a universal single sign-on. Okay, we can do high level OIDC, just to have it in there. Okay. Whew. Okay, so we still need a couple more use case diagrams, or a couple use case diagrams, and to finish the DB schemas. this is good. It's getting good. Okay, thank you everyone. We've got a diagram. We have look at that. We got an actual diagram of the system. We just need a couple use case diagrams, and I think we can pause on this Doorman solution. Okay, thank you.